A fairly standard Edexcel exam question here on inequalities. First bit's linear, so it shouldn't trouble us. Just need to be careful that we respect the fact that you can't times or divide by a negative, but you don't really have to here anyway, because you can just take the minus 2x to the other side here to get 5x is less than 14, so x is less than 14 over 5, 2.8. Can leave it as 14 over 5. Right, b. Now b is an inequalities quadratic type. It's already factorised, so I'm not expecting us to factorise. And it says 1 plus x is less than 0. Well, first of all, we can solve the equation to find the critical values. Let's write that. What that basically means is we're solving the equation and forgetting about the inequality first of all. So we've got x is 7 over 2 and x equals minus 1. And now what we do is we look at this and we decide which way the inequality is going to go. Let's draw it up here. I tend to use a number line approach, but you can use a graphical approach, because if you actually plot the quadratic, we can look for the times it's below the axis, and that's not a bad way of doing it either. I'm going to just use the number line at the moment. Plot them on a number line. So we've got minus 1 and we have 7 over 2. Right, so what we can do is we can say, right, let's go back to blue. Yeah. We can say, right, okay, let's look at the sign of this expression here. Let's look at the sign of it for different values. Now, if x is less than minus 1, this bracket is going to be less than minus 1, and so is this. You can think of an example, just what about if it were minus 2? Where if it were minus 2, then certainly this bracket here would be equal to minus 4 minus 7, which is negative. And this one is also going to be negative, because it's minus 2 plus 1, which is negative. Now, those multiplied together are going to make a positive. So we've got that bit there being positive. Now we can try another value here. 0 is obviously the most convenient to choose. Obviously 0 won't always come in the middle of your two critical values, but when it does, it's certainly a good idea to choose it. So if x is 0, again we can see that this one will be negative, it'll be minus 7, but this time this one, the second one, will be positive. So we've got negative times positive, which overall is negative. Okay, and then this one here, if x is greater than 7 over 2, just make a value which is greater than 7 over 2. It can be anything, it could be 10 if you want. So 10, 2 times 10, which is 20, take away 7, which is 13, that's positive. And do 10 for this one, that's 11, which again is certainly positive. You times in two positives, so we're getting it positive. Right, now here's the thing. We want our inequality to be negative. Okay, so we're looking for the values of x where it is negative. Okay, so it's got to be between these two values. So that gives us the solution to our inequality. So in this case, because it lies between two values, we can nicely write it as one bit. X is greater than minus 1, but less than 7 over 2. Okay, so that's the answer. That's it. Had the inequality gone the other way here, so if we were to reverse this inequality here and it were to be this way, then we would have had our bits coming out here, and our inequality would have been x is greater is less than minus 1, and x is greater than 7 over 2. In this case, you'd have it'd be written with 2 bits on the number line, so you wouldn't be able to write it in one long line like that. You'd have to write it as 2 separate bits. So essentially, just to look at any other question, when it's a quadratic, it will either go, when we look between the things, it will either go positive, both positive, therefore positive, and therefore negative, positive, like it has done here, or it will do exactly the opposite, negative, positive, negative. It'll always do one or the other, and so we're always going to, it's always really just a matter of choosing which one's which. Okay, now we're looking to part B. For part C, we're combining these two. Okay, now so combining these two, I'm going to use the number line I drew above to do this. If I look, I'm still on red now, let's go back to red. If I go back to this bit here, that is x is less than 14 over 5. Now 14 over 5 is definitely less than 7 over 2. It's 2.8 if you work it out. So we're looking for, it's around about that if I write the 14 over 5 here. This is 2.8 and this here is 3.5. So we're looking for the overlap, where it's both of these things. Okay, we're looking for the overlap, and so that just means where both of them are true. So that's x is less than minus 1 and x is less than this 14 over 5 here. And that's it. Okay, pretty standard stuff. If you practice them, you'll see they basically fall into 2 types, really. This one would either be like this. The best wrong answer, if there can be such a thing, is x is exactly the opposite of what it should be. So x is less than minus 1 and x is greater than 14 over 5. That's wrong. But what I'm saying is it's either, when we've solved a quadratic inequality, it'll either be that or that. And what I'm seeing too often when I'm marking students' work is no thought at all going into where the inequality goes. And basically students here writing, just solving the equation and writing the inequality in the same direction as the actual equation has gone. Classic wrong answer, done so frequently. Let me tell you something, that can never be right, so don't do it. Just put some thought into it. At least put some thought into it and get it right, and know that approach will always be wrong. So you might as well not bother. You might as well just leave it like that if you're going to do that. Sorry to be so to be so harsh with this, but really this is pretty standard stuff, and hopefully we can all move on. Thanks. Bye.